Hello, this is a quick video that I wanted to do just to show you how to use the graphing calculator program that I gave you. So you can get your calculator out. If you have the program already, you can try it with me and see if you can get it to work and get all the features that you need for your assignments. So first of all, what we're going to do is enter a function in the y1 space that we have blinking up there. So why don't we put in the square root of x, and that's probably good. We actually did something with this function the other day with the midpoint sum, so we can actually compare our result to what we got there. Alright, so we've got the function entered here. Now what I'm going to do is go back to the regular screen by hitting second and the quit or mode button here, but to get the yellow quit, which is right above it. And now we're going to go to the program button, choosing the NINT2 program. The new NINT2 program may be useful too, but not for what we're doing here, not for the midpoint sum, left-hand sum, right-hand sum. What it does, the new NINT2, just asks for the limits of integration and will basically do the fnint command from the math menu that we looked at the other day and give you an approximation for the exact value of the integral. So what we want to do here is use the NINT2 program to find the left-hand sum, right-hand sum, midpoint sum, trapezoid rule, and Simpson's rule values. So we're going to go ahead and press enter on this once. That just brings it up to the screen, and now you have to press enter again in order to actually run the program. Now it asks for the lower limit of integration, and I think for that example that we did with the midpoint, it was from 1 to 9, so we'll put 1 in and press enter. Upper limit of 9, enter. Divisions, I believe we had 4 divisions for that problem. So we're going to press enter, and it will think and gives us the left and right hand sums. Left first, right second. Lets us write them down if we want, and we have to press enter to go on. It just wants to make sure we can see those before it makes some of it go off the screen. So then it comes up, gives us the trapezoid rule, midpoint sum, Simpson's rule in that order. So trapezoid rule is the 17.22774.019. Midpoint sum is the one in the middle here, and the Simpson's method is this one here. And as you've seen in class, the Simpson's rule does pretty good at giving us values. This is probably the closest to the exact value. This one, 17.38426, should be what we came up with for the midpoint sum. You can compare back to what we came up with there in our notes. Now, if we want to compare these values to the quote-unquote exact value, the calculator will not give us the exact value with the radicals in it, but it will give us the approximate decimal value of that. We can either go to the math menu and use the, go down to 9, fnint option, which we looked at the other day, or I'm going to quit that. We can come back and use the other program that I gave you, which is the new NINT2, which is different. This is just going to evaluate the integral. So pressing enter twice, we run the program. This just evaluates the integral, giving us a decimal approximation of the exact value. It's using something a little bit better than Simpson's rule, but similar idea, still approximating. So here we're going from 1 to 9. Doesn't ask for divisions, and it gives us back a value, 17.33333. So 17 1/3 appears to be the exact answer. I don't think we can go back up here to see what we had above, but you can see that this was close, but still not perfect with n equal 4. We could try n equals 6 or some other even number for Simpson's rule to work. If you do use an odd value of n, we could try that. Let's go back and try NINT2 again. So say we want to go from 1 to 9, and say we use 7 divisions. That's an odd number. That will work fine for the left and right hand sums, as we'll see. And then the trapezoid and midpoint sums are fine. Notice we get 17.35, which is a little closer to 17 1/3 that we're looking for. But for Simpson's rule, it tells us that n must be even for the Simpson's rule, as we know, and so it doesn't give us a value. It's good to know about that as you're playing with these, especially as you do the assignment that you have to do for next week. Okay, well, if you have any questions on it, please let me know. By the way, if you want to run the program again, you can press enter right away after running the program once, and it will run it again right away without having to go back and choose it again. That does save some time, so you may want to know about that. So again, if you have any questions, please let me know. Otherwise, hope this helps get the assignment done faster and easier. Have a good day.